Hello everyone. So far we have completed 5 online lectures. We have started from 6th of July this month. We have finished 5 lectures. So what I want to do, I have created a summary on the board so that I can explain the things in a rapid way, although I am not going in details, I am not going to ask questions. So this is simply a way to summarize everything on the board, and in a quick way I will go across the topics which I have covered so far, and then if you have any queries, then you can write it to me. I will upload this video on YouTube. I will share link with you all, and then you can post your queries. I will answer them in the appropriate way, whether it requires video or it requires audio only. Whatever the best possible solution will be there, I will give you. So we are starting with electronic measurement and instrumentation, EM&I. So first of all, the thing we need to understand is why we are studying this subject. I strongly believe that if I am able to create interest of yours in this subject, then I will be a mere person to teach you this subject. You people will capable enough to study it. So my first responsibility is to make you aware about the importance of this subject and what is the significance of this subject. As you all people are belong to electronics and communication branch, everything is depending upon the measurements. Wherever we are going, you are riding a bike, you have a speedometer in front of you. You are sitting in a car, you are seeing a dashboard in front of you, which is summarizing all the information about the car in front on the dashboard. You don't need to go and see how much petrol is remaining in your car. You don't need to go and see which door is still open, what is the pressure in your tires. Everything about the car is summarized on the board. So measurement is very important, because only creating devices is not enough. Use of them appropriately is actually creating the engineers. So this subject is very important. That's why it has been introduced in 3rd semester. So just see it. It is electronic measurement and instrumentation. Now we start with errors. Before doing anything, what we are facing here, why the errors are coming, what type of errors are coming, we are encountering errors, I want to tell you. So error are of 3 types: gross error, systematic error and random errors. Random errors also have blunders in it. Although few people believe that blunders are not errors, or few people believe no, blunders are also errors. So we will discuss it. So errors can be of 3 types: gross error, systematic error, random error and blunders. Now what is gross error? Gross error is basically the error which is because of human. Means whenever a machine is working, we people are involving with it. Machine cannot work alone. Sometimes it happens that one machine can pass out reading to another machine can pass out reading to another machine, but still there is always somewhere when human is there, who is even ultimately is reading the the output, so the human is involved there. So these are the errors which are causing because of human factors. Like we are doing some calculations and we are creating some errors. So because of human errors, it is arising. For example, when we are using some machine to measure something, first of all we should know what type of appropriate machine we should use here. If you don't have appropriate machine, you cannot find out the correct reason. So the wisdom of the observer says that you have to choose an instrument according to the measurement you are doing. For example, I am telling you, one weighing scale is used by a goldsmith and one weighing scale is used by a vegetable seller. So do you think that both are using same type of weighing scale? The answer is no, because there is a great difference between the sensitivity of the weighing scale of a goldsmith and a weighing scale of a vegetable seller. So we will come on those points gradually, but I want to tell you that the selection of the appropriate instrument, the conditions to use that appropriate instrument, the training required for the person who is going to use that instrument, many things are there. So these things are called as gross errors. Second is systematic errors. Systematic errors, as the name is self-explaining, systematic, it can be of 3 types. It can be instrumental error, it can be produced environmental error, or it can produce observational error. Now understand it. What is instrumental error? Instrumental error means when instrument is having some limitations. For example, if I am telling you we have a mechanical instrument which is having springs in it, do you think that all the materials which are in periodic table and by which we can create a spring have the same life, have the same stretch, have the same tension across it? No. If you will see various materials and you will exploit their characteristics, you will find few are performing well, few are performing not that well. Few can be used for a longer time, their stretchability is still the same as 3 years back, and few are going to not work within 3 months. So it depends what type of material you are using. So instrumental error, we are having bearings in it, we are having springs in it, many things are there, means inside the instrument, if those conditions are not that appropriate, then we can say that those mistakes are because of systematic error. Environmental error. What is environmental error? Environmental error is every machine is not performing exactly same in all the weather conditions. We well know that if we will consider the atmosphere of Jhansi itself, we have a variation from 2 degrees Celsius to 48 degrees Celsius. 46 degrees wide span is there. No machine can have same measurement characteristics in 2 degrees Celsius and 46 degrees Celsius. So temperature is a very big factor which is affecting it. So temperature is there, humidity is there, dust is there, many factors are there which is causing by environment and which is causing error. So the behavior changes, reading changes. Now observational error. Observational errors are what? Parallax. If you are seeing, if your eye is not in the line with the measurement, you will see something else. Approximation. When the needle is between two numbers and you are supposed to find out which is the correct value, you cannot find it. So the guess can be error. So such type of errors are observational errors. Now means random errors. Random errors are basically all the small errors which are coming together in various steps, and when we are accumulating it. In accumulation of the errors, when you suppose you are saying that one error E1 is coming, one error E2 is coming, one error E3 is coming, so the net error E will be E1 plus E2 plus E3. But actually this E will be larger than this E1 plus E2 plus E3. Now what is that delta E which is coming? We don't know. This is called random errors. Many factors are there during measurement which don't have any theory for that, for calculation of its theory. You cannot understand it, you cannot predict it. Random errors, they can come randomly. So those random errors are in this. Blunders are also a type of error. This type of errors are very dangerous, you have to be very careful with it. Suppose you are measuring the length of any rod and it is coming 29.2 centimeter. And because of don't know what conditions or whatever your state of mind is, you are writing 29.2 meters. Can you understand what will happen when unit is changed? This is a situation of disaster. You are measuring something and you are writing something else. Because what is there, sometimes if the calculation is ending here, then too it's okay. But if suppose this calculation is going to somewhere else to take some other decision, what will happen? This mistake will multiply every time. So this is very much problematic. So okay, so these are called as blunders. Blunders are also like this. For example, you want to write 29.2, you write 2.92. You are mismatching the place of decimal. This is again a blunder. So we should avoid these type of things. So to avoid these things where the human intervention is there, what is advisable? We should involve 2 or 3 persons there. So if 2 or 3 persons will be there, what will happen? This mistake can be done by 1 or 2, but if you will repeat it with a various person, then this mistake can be found out. Okay, so this is error, this is about the error. Now come on to some basic calculation. I want to explain 4 things, which is arithmetic mean, deviation from the mean, average deviation and standard deviation. These 4 things are required in minimizing the errors, right? What is arithmetic mean? Arithmetic mean means when you are doing some calculation, the answer is x1, doing it second time, answer is x2, the third iteration is answer is x3, and up to a value of x and it's xn. So what we will do, we can find out the value of arithmetic mean x bar is equals to x1 plus x2 plus x3 plus up to xn upon number of experiments. So this will minimize the error and it will bring you close to the true value, right? It will make you more accurate. Now, what is deviation from the mean? I have explained all the things with so many examples in classroom, so I am not going in detail that. And this is just a quick video. Deviation from the mean. Deviation from the mean is, suppose we have calculated mean x bar. Now we are supposed to find out what is the deviation of mean. Deviation means difference. So this D1 is the first difference, x1 minus x bar. First reading minus the average value. It can come in negative also. So first value minus average, second value minus average, third value minus average. So you can calculate it into a number of times. So this is called as deviation from the mean. Now next is average deviation. Average deviation is D is equals to mod D1 mod D2 up to mod Dn upon capital N. What is this? Why we are using mod here? Because the negative values we will convert it into positive values. So just add all the deviations, divide by the number of experiments, and you will get the value of capital D. We represent it with the value of capital D. And last is standard deviation. Standard deviation is what? The sigma under root D1 square plus D2 square up to Dn square upon capital N. This will give you standard deviation. I also explained it in the classroom with various examples, so it's a quick review. Now come back to these 3 very important points. I want to make it a star here. They are going to come in all your question papers and all. Accuracy. What is accuracy? The shortest definition is closeness to the true value. Whenever you are measuring something and with the help of measurement instrument, if you are reaching closest to the true value, your machine is very accurate, right? So accuracy is when you are finding something and it is giving you close to the true value. If it is giving true value, its accuracy is 100%. Okay. What is precision? Precision is little bit different thing. We need to understand it. Precision is sometimes people get confused with the term of accuracy. But precision is what? Precision means when you are repeating some experiment. When you are repeating some experiment and every time that machine is capable of producing the same accuracy result, then it is called as a precise machine. Are you getting it? Means sometimes the machines behave randomly. Sometimes it is giving close enough value, sometimes it is giving some errored value, sometimes again it is going close. Means the consistency of machine is known as precision. It's a high precision machine. Whether n number of times you will do the experiment, you will get the same value. If I am putting an apple on a weighing scale, it is giving me some result. If I am again putting it, it must give the same result. If I am again putting it, it must give the same result. It means the precision of that machine is very high. Accuracy means the true value, right? Sensitivity. Sensitivity is also very important. Sensitivity is something that minimum value of change in input which we are giving so that it can reflect into the output. That minimum change in the input, right? Are you getting my point? Means it may be possible that sometimes when you change the input bigger with value, but still the output will remain same because it cannot sense the input change. So machines which can sense the input change very quickly are called as highly sensitive machines. The example which I have given to you, that the weighing scale used by the goldsmith, you have seen they are keeping that weighing scale inside a mirror box, glass box. Why it is there? Because they are even so sensitive that if fan is running, they can feel the pressure of what? Air, right? So sensitivity is so high, and In contrast, if you'll go to a vegetable shop, he is giving you 5 kilo of potatoes, and even if if he will add one more potato in the bucket, the output will not change. Can you imagine that? Can this type of error a goldsmith can afford? No, it's not possible. So these are the three terms which are very important. You should understand them. Next is why standardization. I want to tell you why we are going to standardization, because in ancient time, when the things are not that much global, domestic civilizations are there, India is progressing, Greece is progressing, US is progressing, but interconnection is not there. So they were growing domestically. They are creating their own units, they are selling them. वॉल्टर सिस्टम आप लोगों ने पढ़ा होगा. सो बहुत सारी चीज़ें थी जो पैरेलली चल रही थी, बट कम्युनिकेशन नहीं था. बट व्हेन वी कम ऑन द सेम प्लेटफॉर्म, तब हम लोगों ने देखा कि नहीं यार, अब तो कुछ ऐसी ज़रूरत है कि पता होना चाहिए कि जो वैल्यू यहाँ पर है वही वैल्यू उसकी यूएस में होगी. सो व्हाट वी क्रिएटेड सम स्टैंडर्ड सिस्टम. वी क्रिएटेड CGS, MKS, FPS, timely foot pound system, centimeter, gram second, meter, kilogram second. So these systems we have developed. What happened? So these systems we have developed, right? So to make the things global, we standardized. We make unit. We can rest assured that if something is 1 kilogram here, it will be the same 1 kilogram in the US or UK. Next is today itself we have gone through transducers. So just a brief about transducer, then we will end. Transducers are today I have asked this definition to classroom, and I started with the definition of catalyst, and one student answered that catalyst is something which increases the rate of reaction, but parallelly few students corrected, no, it can reduce also. So finally we come out that it can alter the speed of chemical reaction. So now transducers are what? Transducers are the devices which converts one form of energy into another form of energy, right? It can be of many types depending upon its use, its stage, active or passive. They are various types. We will discuss it later on. But up to today, we are supposed to understand it that transducer are the devices which converts one form of energy into another form of energy. Even I did my PhD on antenna, and when I was reading the definition of antenna, one definition was that antenna is a transducer which converts the electrical signal into electromagnetic waves. So in this, what is there? Many quantities are there. Physical quantities are there which have no concern with electrical signals. But for measurement, we want always electrical signal. Then only we can measure it. So what we will do? We will convert those non-electrical signals into electrical signals with the help of these transducers. Okay, so I think you will understand all these terms. Again, queries are welcomed, and tomorrow again we have our class, then we will talk much about it. Okay, thank you, all the best.